where we're going to move pictures to a different location. And you can do that by one, where we're just going to add and subtract, which we'll do an example of that. But if you want it reflected around the x-axis, in other words, if I had to draw a picture, let me just, this is not pretty yet, but it will be when we get our graphing paper. Let's say I have a picture on the x-axis. If I want it reflected around the x-axis, it's going to be the same reflection if I fold on the x-axis. Everybody follow what I'm saying there? Same thing if it's around the y-axis. You'd see the same picture over here, but it would be in the same position. They'd land on top of each other. And if it's reflected around the y equals x line, which is this line, you're going to see the same picture, let's say this, reflected if I fold on that line. That's the first type you could possibly see.
I didn't follow anything you just said.
Okay, all I'm saying is what we're going to be doing is translations and transformations. If I have a picture and it's reflected around the x-axis, means you can fold on the x-axis and you see the same picture. This one is illustrating the y equals x line. If I fold on the y equals x line, won't these land on top of each other?
Yeah.
That's what it's going to be. When you get finished graphing your pictures, if it has x-axis, y-axis, or y equals x line, you can fold on those lines and you'll see the same reflection in that other location. The other types of transformation is counterclockwise. You guys will know what counterclockwise is. Yeah, you're going counterclockwise 90 degrees. So in other words, you're going to take a picture and you're going to rotate it 90 degrees to a different location. Counterclockwise 180 degrees. And counterclockwise 270 degrees. And we have a formula that we use to do that. Which this is, how many of you like video games? Most all of you. Somebody has to do all that good stuff on the computer. And this is what they use. They use matrices, and if they want to rotate it to a different location, like a picture moved to a different location, this is what they multiply by, so that the work is all done on the computer for them. And this is how you can rotate it. Okay, so what we're going to do first is we're going to just do a simple movement of a, let's say, a triangle. Okay, so this is first example you're going to write down. You may have your front side of your graph paper be for, you're only going to have 3 problems to graph basically when we do our exercises. So you're going to have the front side, is it a front back?
Yeah.
Okay, because mine is too. So you can have the front side for your examples and the back side for doing your homework, or vice versa, one of the two, whichever you want. Okay, so let's say that we have a triangle. And yours should look a lot better than mine, since you have actual
We don't need
units.
to write anything on the paper right now.
We will, but not yet. Let's say I have a point at 2, 1, 3, 5, and 4, 2. So there's my triangle. It's at, and I'll write, here's my original triangle. I'll call it A is at 2, 1, B is at 4, 2, and C is at 3, 5. So you need to plot those points and play connect the dots. So you should have a triangle. Now, the first thing we're going to do is we're just going to transform it a different location. So we're going to do, this is what you do on your paper. We're going to involve matrices, because if you were doing this for designing of some video, this is what you would actually be doing. The computer would be doing your work for you. I want to move this triangle to a new location. And I don't know where it's going to end up being, but I'm going to tell you what I want you to do to it. I want you to move it to the right 2 units. So that means I would want to move it, add 2, right? To move to the right. So I'm going to, 2 is going to be all along the x's.
We don't have to graph these yet?
Not yet. Not graph the new one. We just graph the other one. And I'll go ahead and label mine since you've probably done that. So I want it moved to the right 2. and I want it shifted down, let's say 3 units. So if I shift it down, what do I want to do?
Subtract.
Subtract. So I want a -3 to go down. And here's where the matrices come in. We know how to add matrices, right? We've already done this. What do we do to add? Each respective position, so 2 plus 2 would be
4,
4 plus 2,
6,
3 plus 2.
5,
Now we're shifting it down 3, so that would be
-2,
-2
-1, 2.
and 2. So this gives us the new vertices. A different triangle moved to a new location, and that location is 2 to the right and down 3 from whatever it was. So now, what's our new matrix, or what's our new triangle? It's
A,
4, -2.
B, 6, -1, C, 5, 2.
How do we graph these? I don't know how we did that.
Just ordered pairs.
Like, how do you make the order pairs of these?
Each row, each column gives you a vertice.
What if it has 3 rows?
We aren't gonna have one, that'd be 3-dimensional. Okay, so where is 4, -2 located at?
Right, 4 down.
Right, 4 down 2. Okay, then my next one, where's 6, -1 located?
Right, 6 down.
Right, 6 down 1. And the last one, where's 5, 2 located?
Right, 5 up
1, 2, 3, 4, 5, up 2. Now, is it the same size triangle?
Yes.
And has it just been shifted to the right 2 and down 3?
Yes.
So that's just a simple translation. Does everybody follow what we did there? Okay, now, let's say I take, so that's one example. I think this is like this example is like 12 through 14. They're gonna have you do a series of 3 problems. One will probably be just simply plot the points. Then they're gonna tell you to shift it to the left 5, up 6, something, where it gets you this transformation here. Then you add it together to get your new triangle. So I'm going to use the same triangle we started with, and this time we're going to do one of our custom design that we want to do. And you guys are going to tell me which one you want to do. Don't let you pick. So does everybody follow this one so I can erase this part?
Yeah.
So I'm going to leave A because it's going to be the same one. Which would you guys rather see? Would you rather see it reflected over the x, reflected over the y, reflected over the y equals x, counterclockwise? Nicholas?
I was gonna ask if we could put this on a different graph. 'Cause
Yes, you will. You want to put it on a different graph. I'm just doing this to save me creating a new graph. So yes, this is example 2. And example 2 is going to be like what you're doing on 18 through 20 and 21 through 23. You're going to use one of these formulas to multiply. Okay, so which one would you guys rather do? Would you rather do a reflection or would you rather do a counterclockwise rotation?
Counterclockwise.
Okay, which one do we want? 90 or 180 or 270?
270.
270. I heard 270 twice. Okay, here's the most important part. I stated it in the very first thing. It says multiply the vertex matrix on the left. So that's the part that you have to have. Which I didn't take my pen. Pen belonged to you. It has to be on the left of our equation. So we wanted to do a 270, right? Okay. So we have 0, 1, -1, 0. That's the one we use. Whichever reflection you want, you choose your formula from this page. Now, what's my vertexes of my original triangle? 2, 1, 4, 2, and 3, 5. Does everybody see where I got those? So it's whatever they give you as your original, whether it be a quadrilateral, a pentagon, or whatever it is, you put that in the second matrix. So that's the most important part. This always has to be to the left. Why is that? We mentioned that Thursday.
Because they're,
Community property does not work in matrices, so you have to be very careful about the order you do things. So it has to be to the left. Okay, now, don't we know how to multiply? How do we multiply matrices? Row by column. Okay, so everybody should be able to help me here since we did this last week. So Robert, what would be first row, first column when you multiply?
0 plus 1.
Okay, so that was 0 plus 1, I agree. Nathan, what would be first row, second column?
We'd have 0 and
0 on what?
2.
Mhm.
I forgot exactly how to do this.
Row by column. So I just did Robert just did the first row, first column, so it'd be 2 times 0 plus 1 times 1. So that's 0 and 1. Then Nathan did first row, second column, 0 times 4 plus 1 times 2. Now, we're ready for Aaron, first row, third column.
0, 5.
0 plus 5. Okay, now, Dylan, you get second row, first column.
-2 minus 1.
Try that again.
Oh, 0.
Remember to move. Okay, Nicholas, let's try you. You get second row, second column.
-4 plus 0.
Good. Spencer, you get second row, third column.
-3 plus 0.
Now, Jesse, what do those add up to be?
1, 2, 5, -2, -4, -3.
Let me move that 5 over, it looks like it's right next there. So that creates the new vertices, doesn't it? So this would be A, B, and C, and I just call them prime because it's a different. So what do I have? 1, -2. B prime is 2, -4.
We need to write it like that.
No, I'm just doing it so anybody that needs that extra step has it. Now, we're ready to plot those points, so, Andalyn, how would I graph 1, -2 at?
1 -2 would go right from the origin and down to,
What about the next one?
right 2 and down 4,
Okay, and the next one?
and right 5 and down 2.
So then we're going to connect. And this one, what did we do? We rotated it counterclockwise 270 degrees, which means, think about it, visually, if you're doing this video game, it's going like this, little at a time, all the way 270 degrees. So it's going to flip the C, which it did. You guys see where it's no longer up top, it's on the side. And the B is going to be flipped, and the A is pretty close to the same location, but not quite. So it should show a rotation of counterclockwise 270 degrees.
Or clockwise for 90 degrees.
That would be true. Okay? So do you guys follow where we get this? It comes from our page of formulas. Okay? We can do another example. Let's create, this one you don't need to write down, we'll just make it up. So this is an example again of 18 through 20 and 21 through 23. Let's do a rotation that does a reflection. Let's say that I pick this time not a triangle, but a quadrilateral. And let's do a reflection where it reflects it around the y-axis. What's that mean? If I fold on the y-axis, my graph should end up looking in the other land in the other axis there. It looks pretty much the same. So let's call this A, B, C, and D. So we need to get our vertices. What are my vertices? A is what? 1, 2, 3, 4, 5, 1.
1.
Yes. B is what?
-2, 1.
C is what?
-1, 4.
And the last one, D.
-4, 4.
Okay. Now, we want to rotate this one, I said, so we want it to be transformed to where it has y-axis reflection. So what formula do I take for y-axis reflection? And it always goes to the left. I take the -1, 0, 0, 1. Okay, now, what's my matrix, my vertex matrix? That means you take your vertices from your quadrilateral.
-5.
-2, 1, -1, 4, -4, 4.
And then you multiply.
5 row by column.
Row by column. So we're ready for Tatum. I think you get to do row 1, column 1.
Okay, so 5 plus 0.
Marilyn, you get row 1, column 2.
2 plus 0.
Riley, you get row 2, column 3.
1 plus 0.
And the last one, Carissa, you get row 1, column 4.
4 plus 0.
Okay, so we're back to Robert. You get row 2, column 1.
0, 1,
Nathan, row 2.
0,
Aaron, you get row 2, column 3.
0, 4.
And the last one, Dylan, you get row 2, column 4.
4.
So that creates,
5,
well,
2, 1, 4, 1, 1, 4, 4.
so my new vertices will be,
A is 5, 1, B is 2, 1, C is 4, 1, and D is 4, 4.
okay, so 5, 1.
Now let's see 4, 1.
1, 4.
Oh, 1, 4.
Yeah.
Thank you. So 5, 1, 2, 1, 1, 4, and 4, 4. Mine are kind of cockeyed, but do you see where it would reflect?
Yeah.
And especially if you do it on graph paper, you can tell it right off that when you fold it, it would look the same. Okay, do you guys follow what you're doing today?
Yeah.
Okay, so it's page 179, 12 through 14, which I'd like to see your first one when you get it done, this section. It's like one set per problem. They have you do multiple things. They're 18 through 20 and 21 through 23. Pay attention to which rotation or transformation they want you to use so that you multiply correctly by the one and make sure it's always to the left. You guys have questions?